In this video, we will be building the backend for a ticket booking system using Spring Boot and Java. This app will follow Microservices Architecture, where multiple independent services communicate with each other using Kafka queues and REST APIs. As you can see from the diagram, these microservices will share a SQL database for storing data. I'll guide you step by step through building each microservice and connecting them to form a functional ticket booking system. However, we won't be implementing a full-fledged system. Instead, we'll focus on the essential components needed to understand how microservices architecture works in practice. On screen, you can see the key technologies and concepts we'll be covering in this video. If you have any questions, feel free to drop them in the comment box below. We'll start by building the inventory service, which will handle event and venue information. Let's dive in. So the inventory service is this part of our diagram, and as you can see, it will be called by the booking service, and it will call the MySQL DB where the information will be stored. This will be based on Spring Boot and Java 21. On screen, you can see a list of prerequisites that you need to have installed on your laptop to follow this along. So pause the video and install what you see on screen. Okay, let's build our Spring Boot application. So go on Spring Initializer and let's create an initial project. So it will be using Maven with Java. We're going to use Spring Boot 3.4.2. Let's give it some names. I have already filled it down here. I'm going to call it inventory service, and it's going to be packaged using jar, and we will be using Java 21. We need some dependencies. So the first one is Spring Web. We are then going to need Lombok. This will avoid us writing a lot of boilerplate code. We will be using Spring Data JPA. It's a powerful technology used in a lot of enterprise applications. And we will need a MySQL driver to actually connect to our MySQL DB. Finally, we are going to need Flyway, a migration tool. Don't worry, I will explain these concepts more in detail as we'll use them throughout the video. We have these dependencies. Let's generate the project. Let's open it using an IDE. I've opened the downloaded project in IntelliJ, and we can start writing some code. The first thing we need is a controller class. The controller is the entry point to our service, so it will be the one that will have the endpoint that will be called by external applications. So let's go to this package, and now let's create a new package called controller. And in this controller package, we're going to create our controller class. So I will call it inventory controller. And this is going to be a REST controller. And we're going to add the request mapping at a top level, so API v1. As I said, this inventory service is going to return information about events and venues. What we can do is we can first create an endpoint that is going to return all the events with the capacity. We could have something like a get mapping. It's going to be, yes, inventory events. And it's going to be a public method that's going to return a response body of type list, as we're going to have multiple events being returned. So I have CodePilot installed and it's giving me suggestions. We're going to call this object event inventory response, and it's going to get us all the events. To get these, we will be calling a service class. So don't worry if they're red. We're going to create these objects. Let's now create this response object. To do this, let's create a new package that will contain our response objects. And let's call it response. In here now, let's create a new Java class, and we will call it event inventory response. Let's leave it as is. So let's not put anything in there, and let's import it in our controller. Let's also import list. So one red is gone. By the way, this event inventory response needs to be in the response package. So I'm just going to quickly refactor. And now in here, let's create a new package for our service class. And let's call it service. And inside this package, let's create our inventory service. And if you go back to the controller, it's still red, and that's because we need to actually inject the inventory service inside the controller. We need to tag this inventory service class as a service class. And now if you go back to our controller, we are going to create inventory service. We are going to inject it using an auto-wired constructor. So as you can see, I've created a constructor with this inventory service, and Spring Magic will deal with this. So you don't have to worry too much about this. So now this is not red anymore, but this is red. And that's because we don't have a method called getAllEvents in the service class. So if you go back to the service class, we now need to create this getAllEvents method. We have a suggestion here by Copilot, but this is not correct because we do want to return a list of event inventory responses. So now that we have removed the errors from the controller, we need to come to our service class and start populating in here. So we want to return all the events, but these events are stored in a MySQL DB. So the first thing we need is to run a local MySQL DB instance. We need to populate this DB with some tables and columns and values. Let me show you the diagram of the database schema that we will need for inventory service to work. So this is the schema of our database that we will need for inventory service. As you can see, we will have an event table and a venue table. So the venue table will contain all the information regarding the venue, a name, total capacity, and the address, whilst the event table will contain a list of events. In this case, an event has a total allocated capacity. Let's say a venue has 80,000 seats. We can have multiple events running at the same time in the same venue. So the capacity could be split, 50-50 or 60-40. So that's why we have a total capacity for an event. And then we have this other attribute called left capacity. This is the capacity that is left in this event and that we can sell to customers. It represents basically the number of tickets that you can still sell. And this event is going to be hosted at a venue. So we have a foreign key that connects back to this table. So now we need a way to handle these tables in Java. And to do that, we will be using Hibernate and JPA. And let me show you how to do it. It's not that complicated. So if you go back to our service class, we are going to need two repositories, one for the event and one for the venue. So I'm going to create two repositories. One is going to be the event repository, and the other one is going to be called venue repository. And we're going to do the same thing as the controller. We're going to create a constructor and inject these two in here. These are red because they don't exist. So we need to create a package called repository. And in here, we're going to create two interfaces. So the first one will be called event repository. So this has to be an interface. Let's leave them here for now. Let me create the other one for the venue. So you might be wondering why I'm creating multiple repositories. It will be clearer soon, but the model you should follow in Spring Boot is each table in your database is going to have an associated repository class. That repository class will have some kind of entity object reference to let Spring Boot know what are the columns and types of these objects stored in the MySQL DB. It might be confusing now, but it will be clearer in a bit. So we have created these repositories and we need to add some tags. So this is a repository and it extends JPA repository, and we need to give it a class that represents the table inside our SQL DB. So we will need a venue class, and this long represents the key type of this object. We don't really need this. We now need to create a venue class. For this, we're going to create a new package called entity. In here, we can create a new class called venue. We need to add some tags on this venue class. So it's going to be an entity class. We need some getters and setters. We need constructors, and we need to define the table name. So we need to put here the name of the table as it will be in the MySQL DB. So I will be calling it venue. If we go back to our table, these are the columns we'll have in the venue class: an ID, a name, total capacity, and address. We need to have those represented here as class attributes. So this is going to be ID. It's going to be a long. Let's also put the column name as they will be in the SQL database. So the next one is a name, and it's going to be a string. We are then going to have a column called address, which is going to be saved in a string. And lastly, we'll have a total capacity, and this is going to be a long. So error here is gone. If we go to the venue repository, we can import our venue class. We have imported our venue class and the errors here are gone. Now, if you go to the event repository, let's fix this one. This one needs to extend. And we will be having an event class representing the event table. If we go into entity, let's create an event object. We can go to venue and we can copy these tags and then we can modify them. This will be called event. And if we go back to our SQL schema, we need to have these columns in the event class. So ID, name, total capacity, left capacity, and venue ID. So let's start by creating the ID. This will be a long. Then we'll have a name, which will be saved. The name here is the event name. Total capacity. This will be a long. And then we have a left capacity. We need a way to represent this foreign key. You might be thinking, oh, it's probably just going to be, because it's an ID, it will be a long. But no, this will actually be a venue object. It's going to be a venue. We need some tags. We need to explicitly tell the relationship. So it's many to one. One location, one venue can have multiple events. This is a join column. The name of the column is actually venue ID. If we go back to our event repository, we can now import the class. And the error is gone for now. So now let's go back to our service class. Let's fix these errors. Let's import these classes. And as you can see, we are at a good point. We have some red here, and that's because we need to return something. How can we do that? We're going to query the MySQL DB using these repository classes, and we will get back a list of events. we will be using the event repository, and we will be calling this find all. This is part of the Spring Framework data repository, and you don't need to do anything else. And now we want to return these as a list of event inventory responses, and we can simply just build this. So this is red, and that's because we have not declared what we want in our event inventory response class. So let's add some tags. Let's have a builder class, no arg constructor and all args constructor. And here we will be returning the event name, the capacity that is left, and a venue. As part of each event retrieved from the DB, we will be returning this information. So if we go back to our service class, we can also add the venue and then do event.getVenue. And that's all we need so far. Now, if we go back to our controller, we have implemented this endpoint to get all the events. Let's now implement another method that is going to return us information about a specific venue. So it's going to be a get mapping, and it's going to be inventory location, and we want to get information about a specific location, or actually we should call it venue. We are going to pass a venue ID, and we are going to return a location inventory response. So we will need to create this object later. So we will accept as path variable a venue ID, and we will pass this to our service class. So we'll call it get venue information. And we need to create this location inventory response, and we'll create it here in the response package. Let's just copy these ones from the event inventory response. And in here, we will be returning the ID of the venue, venue name, and also total capacity. I think that's enough. So if you go to the controller, we can import our inventory response class. Now we need to create this method in the inventory service. So if you go in the inventory service class, let's create a new method that returns location. Actually, we should call it venue inventory response. So let's refactor quickly. And we will be returning a venue inventory response. Get venue information, that's correct. We will be querying using the venue repository class by ID. Again, this is a method provided in the data repository package. This will be returning a venue, and then we will be building a response object with this venue class. So if we go to our controller, it all looks good. We don't have any warnings. Next step is to have a MySQL database instance running on our machine. To do that, we're going to use Docker Compose. So I have created a Docker Compose file, and this is what you need in it. You need to define the image you want to use. So we'll be using MySQL 8.3.0. Define the container name, give it a password, and give it a database name. So we will be calling it ticketing. Let's give it some volumes. We will be required to provide an initial SQL file so that we have a database created on SpinUp. So to provide this initial SQL file, we need to create this structure. So if you go in inventory service and we create a new directory and call it Docker. And in here, we're going to create another folder called MySQL. And in here, we'll create a init.sql file. So in this file, we will be creating a database if it doesn't exist called ticketing. And then we will be using this ticketing database. So that's all you need so far. Now let's use Docker Compose. And let's spin up our image. So let's see if it goes through without any issues. So the container has been created and it has actually started. You can do Docker PS and you can see that it's actually running on port 3360. To see if this database has been created, I suggest you download MySQL Workbench. Once you have downloaded MySQL Workbench, we can create a connection to our local database. So I will call it ticketing DB. And host name, it's fine, just leave it as is. Username is the one you have provided. And now if you click on test connection, let's provide a password. And this is the password you have defined in the Docker Compose file. So in this case is password. If you get a warning, just ignore and click continue anyway. And the connection was successful. Now if you close this, double click, continue anyway. Now we can see that our database called ticketing has been created. We now need a way to create these two tables in the MySQL DB. We have various options. We could simply go and create these two tables manually using DDL commands. But the best way that it's actually used in the industry is to use a database migration tool. And the one we will be using today is called Flyway. So Flyway is a migration tool that is quite popular and there are various ways to run it. We have already imported the dependency in our Maven home.xml file for Flyway when we went on Spring Initializer. So we will be using this migration tool. The reason is, let's say you are doing changes manually to your DB, but one of the changes fails. You need to revert back to the previous version and it might not be easy to revert back. What Flyway does is it creates a database sequentially using a step of migrations. And another benefit of this is that, let's say another developer joins the team and he wants to recreate this database on his local machine. He can simply run this Flyway migration, which will run as part of our Spring Boot app, and he will have a fresh database in the same state as another developer in the same team, without having to ask anyone to give them the create statements to get the DB in the same state. This tool helps in migrating the database from one state to another. So we need to configure this and we need to configure a bunch of other stuff as well. So if you open application.properties, in here, you will need all these properties. So we will be running our inventory service on port 8080. This is the URL where our MySQL DB is running. So this is the name of the database and this is the port, username and password. We will be using the MySQL driver to connect to our SQL DB. And importantly, you need to add this property here. We don't want Hibernate to automatically be updating DDLs because we have decided to manage them manually using Flyway. So how can we create these tables using Flyway? You need to go into the resource class, and inside the resource class you need to create a directory called DB, and then inside that you need to create another one called migration. And now in here we are going to create our migration files. You need to follow a naming convention for the files. You need to have v and then the version. In this case it's the first file, so it will be 1, double underscore, and I'll call it init.sql. This part after a double underscore, it can be anything that describes your migration. We will be creating our venue table. Now we have our first migration file called v1 init.sql, and in here we're going to put the instructions to create our table. So we'll first create the venue table and then we'll create the event table. We are now ready to run our migration. Let's do a clean install. If we go to MySQL Workbench and if we refresh, we can see that these three tables have been created. This table here, Flyway schema history, if you actually retrieve what's inside, it tells you the scripts that have been run, if it was successful or not. So in this case, this has been successful. Now we need some data inside these tables. So let's put some data. We can do it in MySQL Workbench. So insert into ticketing.venue. Let's create the venue first. Let's see what we require. So we're going to pass a name, address, and total capacity. Let's give a name, Old Trafford, address, Manchester, and capacity, let's put 80,000. Let's also have another venue. Manchester, capacity, I don't know, 70. Let's run this. Let's see if this was successful. Yes, we have a venue and we want to do the same thing with the event. Let's add a couple of events. So insert into ticketing.event. We want a name for the event and left capacity. So first event, let's call it call play, and okay, let's put some 30,000. Let's insert, and let's see if this insertion was successful. Okay, so now we have data in our database. The last step left is to check whether our endpoint is actually working. So we have two endpoints in our controller. One is going to return all events, and the other one is going to return information about a specific venue. We are now ready to test our endpoints. What we need to do is to run this application. So we need to create a configuration in IntelliJ. So click Edit Configuration. Let's create a new configuration for an application, and I'll call it Inventory Service. And the main class is our Inventory Service application class. And just click Apply and OK. Let's run this. Okay, so the application has started. We can now open Postman. So Postman is an industry tool that is used by a lot of engineers to test APIs, and it's quite powerful. Click on the plus, create a GET request. We are first going to test the details about a venue. So as expected, this is returning venue ID 1. Let's try with 2. 2 is working as well. We have not added any error handling, so if we were to try with 3, this will 500 as expected. This is working. Let's try the other endpoint, which was inventory and events. So this is going to return all the events happening. If we click send, we get back a list of events with their venue information. Bruno Mars concert is happening in Etihad Stadium. This was correctly returned with the correct venue, address, and all the information. So we are now in a very good position to move on to the next service. So inventory service, we can put it on a side for now, but we are still going to need it as part of our microservice architecture later. We will also be using this project to do all the migrations on our MySQL DB. So if we are going to need other tables in our database, we'll just add them here. That way we'll have a single service that is going to have all the DB migrations. There are also other ways to put them in different microservices, but to not confuse you guys and to keep it simple, all future DB migrations will go in the inventory service, and to run the DB migration, you can simply just run the application or do a Maven install, and it will run through the migration and apply those changes on the MySQL DB that we are running. We are now ready to move on to the next service. So we are now going to move on and build our second service, which is the booking service. So this is the heart of our whole system, as we will be placing a ticket order, and the entry point to this placing the order will be the booking service. As you can see in this diagram, I have added some arrows with some labels. The flow will be something like booking service will get a request to place order for an event for a specific customer. Booking service will first check that the customer actually exists. If the customer exists, we will then go to inventory service and we will get back the inventory for a specific event. What that means is we will get back information about the capacity left for a specific event and the price of a single ticket for an event. So to do that, we will need to create a bunch of other tables, and we will need to modify the event table as well in order to add the ticket price. So once we have inventory, what we will do next is we'll build an order event, and this event will be placed on a queue. And this queue will be implemented using Kafka. I will explain that more in detail later. And then order service will pick up this message from this topic and save it into our SQL DB. And then it will send a request to inventory service. And this request will be used to update the inventory. So you might be asking what's async and what's sync. Sync basically is a synchronous call. Booking service will send a request. It will wait for a response from inventory service. Whilst in this asynchronous call, booking service will place the message on a topic, and then order service will pick up this message once it is able to process these messages. The advantage of having a queue here means that if we were to get a spike in orders through our booking service, we would not overwhelm order service, and at the same time, we would not slow down operation for other clients. So let's say we get 500 requests per second. Booking service is going to create these orders and put them on a queue. And then order service will take its time and pick up each message, save it to the DB, and then update the inventory service. As you can imagine, we might have some issues with inventory, as we might get more orders than we have inventory. We are not dealing with that logic here. Actually, that could be a nice extension you can implement in your own time, and you can think about how to implement it technically. But I try to keep it simple here. We assume we're going to get a normal flow of orders, and the main focus here is to show you how to use a Kafka queue. This is the flow. We will need to do some SQL changes. Let me show you the database schema. This is our new database schema. Previously, we just had two tables, venue and event. Now we need to add a new attribute inside event, a new column, which is going to contain the ticket price for this specific event. And then we need to create two new tables, the customer table and an order table. This order table will be the main table of our whole system because that's where all the orders will be saved. We will create these using Flyway migrations. So we will do a DB migration, and I will show you how to do that. In this part, we will need to extend the inventory service to do our DB migration, and we might have to add 1 or 2 new endpoints. But don't worry about that, we'll cover everything in this part. We are almost ready to start. So the next thing we need is to create a new Spring Boot project. Again, go on Spring Initializer. We're going to use Java, Maven, and Spring Boot 3.4.2. Give it a name. I'm going to call it Booking Service. Java version is going to be 21. And then we need some dependencies. So we need a MySQL driver. We need Lombok. We need Spring Web. We need JPA, And we also need Apache Kafka. Spring for Apache Kafka, so make sure you select the first one. Now let's generate the project and let's open it in IntelliJ. I have opened the booking service project we just downloaded in IntelliJ. The first thing we need to do is do something very similar to inventory service. So we're going to have an endpoint people can call to do a booking. Let's start by creating a package where we are going to have our controllers. So right click, new package, and we'll call it controller. In here, we're going to create a new Java class, which is going to be called booking controller. This is going to be a REST controller. We're going to put a mapping and API v1. This is the standard usually. Next, we want to create a post endpoint where we'll get the actual booking. This is going to be a public method that's going to return a booking response. And we'll call the method createBooking, and this will get a booking request as a request body. We are going to have a service class. I'll call it booking service. And we'll pass the request to create our booking. We have quite a lot of red. Let's start importing the request body. And next, let's move on to the post mapping. So users will be calling this booking endpoint, and as part of this booking endpoint, they will be sending a request body. And in this request body, we'll have an object that will be the booking request. So we'll create these objects in a minute. And all of this will be returning a booking response. Once the booking has gone through to the Kafka queue, we'll send back a booking response. I'll show you how to build this in a bit. But first of all, let's create a service class. So we need a new package and we'll call it service. In here, create a new Java class called booking service. And let's annotate it with service, as this is a service class. Now let's go back to our controller. Let's inject that service class into the controller. And let's auto wire our constructor. So far, so good. So this is not red anymore. We have to create a booking request and a response object. To do that, we can have two packages, one for the request objects and one for the response objects. Or we could have a DTO package where we're going to have all the requests and the responses. A DTO stands for data transfer object. I think for clarity purposes, I'm going to keep them separate here. We create a new package. This is going to be called request. And in request, we're going to put our request object, in this case, booking request. And we're going to create a booking request object. Let's add some annotations. So data, let's have a all args constructor, no args constructor, and also a builder class. Let's leave it blank for now. We'll see later what we need in a booking request. Let's import. Next thing, we need the booking response. So let's create a new package and we're going to call it response. And in response, we'll create a new Java object and we'll call it booking response. Again, let's add some annotations. So it's going to have data, constructors, and the builder class. Again, we'll come back to this later. For now, let's leave it empty. Let's import this. Okay, so a lot of red is gone. We want to create a create booking method in the booking service. So in here, let's create a public booking response create booking. And as input, this is going to get a booking request. And then it's going to return a booking response. we can see that there are no more errors in here. So let's go in the service class. So now in this create booking method, we need to do some operations. I wrote them down. We need to check if the user exists, check if there is enough inventory. When we get the inventory, we'll get the event information with the ticket price per unit as well. We then need to create a booking object and send this booking object to order service on a Kafka topic. So let's go back to our controller and let's try to see how our request will look like. So if we open booking request, we will be expecting a private long user ID, and then we need to know which event we're trying to book, a private long event ID. Is there anything else we need? We need the ticket quantity. So we need to know how many tickets they want to book. I'll call it ticket count. So these three are the input attributes that will form part of the booking request. So far, these three are the attributes we'll need to place an order. Let's go back to our booking service. The first step is to check if the user exists. And we need to actually go into the database and see if the user is present in our DB. As I explained earlier, we don't have customer table or an order table. And we also need this new column in the event table. This is how our database looks like so far. We have two tables, event and venue. And we have only one migration. Open inventory service, and we want to add a new DB migration in here. So if we go to DB migration, let's create a new file called v2. And the first thing we'll do is add the ticket price to the event table. So I will do add column event table. Let's get rid of that. So we are going to add a new column called ticket price. It's going to be decimal, and we also want a default value. So we already have entries in our event table. So we want to assign the ticket price to also these events that are already there. For that reason, I've added a default value of 10. I'm going to run inventory service so that the migration goes through. If we go back to Workbench and if we query again, we can see that another column has been created with some default prices. And if we open Flyway, we'll see a new migration has been added. Let's now create a customer table. So we're going to have a new migration. This is going to be v3, and we'll call it create customer table. We want to create a table that looks like this. And we can already add another migration to create an order table. So this will be version 4, and we'll call it create order table. I hope you're able to see how useful Flyway is. We have everything versioned, and we have a history being created of how our DB changed. So this is how our order table will look like. Just notice I have two backticks here, and that's because order is a reserved word in MySQL. These two ticks are a must. Just keep that in mind. So let's restart, and hopefully these migrations will go through as well. So we have an error here, cannot be not null. So let's remove the not null, and let's try again. Yeah, so that makes sense, because on delete we're going to set them to null. There are various ways you can handle on delete, cascade or set null in this case. So I think that's what it's complaining about. Let me rerun it. We have another one. So we might have to go into our MySQL workbench and see what's going on in here. As you can see, the last migration was not successful and it's showing as a 0. We need to delete this. I think that's the reason why it's failing. So let's do a delete from this table where version is equal to 4. So let's delete. Okay, so if you see this this error code, you're using safe updates mode. What we need to do is we need to set safe modes to off. So you can do this by running set SQL safe updates equals to 0. This will allow you to delete stuff. Now that you set that, we can delete, and this time it was successful. Let's go back to the inventory service and let's run it again. This time looks like the migration was successful. If we come back to Flyway, we can see that this was success, and if we refresh the DB, we have a new order table created. So we have done the migrations we needed. We can now go back to our booking service to carry on implementing our booking endpoint. So now we need to check if a user exists. We need to query the user table. To do that, we need a repository class. So it's going to be called customer repository. And then we're going to auto wire it to our booking service. So this is giving error. That's because we don't have that repository class. So we're going to create a package called repository. And here we'll have our interface. And this interface will be called customer repository. And this one extends JPA repository. And it will be a customer. It will represent a customer entity, and the ID of each entry will be a long. We need to mark this as a repository using the repository tag. So we now need to create this entity class. Let's create a new package called entity. You might be thinking, oh, this is an overkill. We have so many packages for not much code. But just imagine you have a big service with, instead of 10 endpoints. This is going to be quite useful in maintaining order within your project. So let's create a customer. This is an entity. Let's add data. No args constructor. Let's add a builder, and this will represent a table, and the name of the table is customer. We're going to have few attributes in this customer table. I'm gonna go to our migration and just copy this for now, and I'll put it here as a comment. We've got a name, we've got an email, and we have an address. And that's all we need so far. We need to define a primary key, and this is the primary key. We're going to use the ID tag, and as you can see, the error is gone. If you go back to our customer repository, we can now import this class, and the error is gone. Let's go back to our service class, and let's import it here, and the error is gone again. So to check if a user exists, we can do something very simple. Let's create a customer called customer, and what we're going to do is customer repository find by ID. We're going to pass the ID of the customer. So from the request we'll get the called it user ID. This is an error because this returns an optional. So we want to do or else let's return null. So if this customer does not exist, we'll just return null. If customer is null, we can throw a runtime exception. If you're following the logic, we'll check if the customer exists. If it doesn't exist, the repository will turn a null and we'll simply throw an error saying user not found. If the customer does exist, next thing we need to do is to check if we have enough tickets to be sold. To check inventory, we need to go back to our inventory service and let's open the endpoints we have available here. So let me close this. In here we have two endpoints, one that gets all the events and another one that gives you the inventory by the venue ID. What we could do is possibly get all events and then match the event we actually want to book for and see if there is enough inventory. But if we open our response object, we do have a capacity, but we don't have ticket price and we don't have the event ID so that we could use that attribute to match for our booking. So we will need to create a new endpoint in our inventory service. And this endpoint is going to return the inventory for a particular event. And it's going to return an event response. We need to pass an event ID as a path variable. We need to create a new method in our service class. We'll call it getEventInventory. And if we go in our service class, let's create a new method eventInventoryResponse. Let's see how this looks like. So we're going to pass an event ID. We'll find the event in our event repository using the ID, and then we'll send back an event inventory response. We need to do some changes to this response object. So let's add an event ID and let's add the ticket price. This is going to be a big decimal. And we're going to call it ticket price. So if you go back to our service class, we need to add ticket price. So event does not have this method, and that's because we forgot to do something. We added the new column, but we did not add it in the corresponding entity. So let's add the new column. This is called ticket price, and this is a big decimal. The error is gone, and we also want to add the event ID. I think that's good for us. Actually, we need to pass the event ID. Let's have a quick check. So we're going to pass an event ID, and this event ID will go to the service class. We'll query the event repository, and we'll send back a more complete event inventory response. So I think we've got what we need from the inventory service. What we need to do here is now call our inventory service. So to call inventory service, we need to create a client, and this client will be used to call the endpoint in inventory service. So we need a new package called client, and in here we're going to have inventory service client that we'll use to make all the calls going to the inventory service. Let's leave it for now, and let's go back to our service class and let's auto wire it. If we go back here, we need to add it to our constructor. Now we can focus on our inventory service client. Our client class is going to be of type service, so let's add that annotation. Next, we want to create a public method which is going to return an inventory response. We're going to call it getInventory. We're going to pass an event ID, and then we're going to do a synchronous call using a REST template. So let's create a REST template. Let's import. The next thing we need is a URL for the service where we want to send this request. So we're going to put that in the application.properties. if you open resources and you go in here, we can add a new property. We'll call it inventory service.url and make sure you've got the right port. And you can find this one in the inventory service controller. Let me quickly show you. So if you go in inventory service, this is the endpoint we want to call, and this is the base of the request URL. And then we've got this part here, inventory. This is common to all three of them. Actually, we could put this one up here, but let's leave it as is for now. So we've got API/v1/inventory. Let's go back to our client and let's add it here. So we can import it from the application.properties file using this tag called value. Make sure you're importing the right tag, not the one for Lombok. And simply this will be imported from the application.properties file. And now we can see that this is red. We don't have this class. It doesn't exist. So this is going to be a response. Let's go into the response package and let's create an inventory. So inventory response. In the inventory response, we need to add some attributes and we need to add some tags. So let's add the data one. Let's add constructors. Let's add builders. So what are we expecting from inventory service? So you would usually get this information from our API documentation. In this case, we can go to inventory service and inspect our event inventory response, which is the return type of our endpoint. So we can simply copy these attributes. Let's go back to booking service and let's paste. As you can see, we've also got a venue object, and in this case, we want to call it venue response. And we also want to create a venue response class in the response package. Same as before, let's go to inventory service. Let's open venue. We can copy these attributes and let's remove these tags. We don't need these. And let's add some tags up here, data and the builder. We don't need these ones. Our inventory response is now good to go. Let's go back to our client. Let's import this class. And now we are ready to make the actual call to inventory service. So we can simply do a return REST template get for object. We just want the body. We are going to send it to inventory service URL, which we get up here, /event, and the event ID. And this is the return type, in this case, an inventory response. And this inventory response will be returned back to our service class. So if we go to our service class, we can now add the next step. So here we are going to get an inventory response. We're going to do a call using inventory service client. We're going to get the inventory for a specific event ID. And we can actually, for debugging purposes, let me show you that what we got so far actually works. System.out.println, and let's print the inventory response. Inventory service response. So we've got what we needed from inventory, and let's check that our client works and that we can actually get our customer data back. So the way we're going to do this is we're actually going to be running both booking service and inventory service. And I will be calling this booking endpoint in our booking service. So let me just show you. If we go to our controller, I will be calling this booking endpoint here. One thing we need to add in our controller are some extra attributes in the post mapping. So in here, you want to add consumes and produces. This is going to tell our application what we want to consume and what we want to produce. And then we need to add a label for our path, which has moved here in the end. So we've got our endpoint to call. We need to do some configuration. If we open application.properties, we need to define few things. So the first one is actually the port. 8080 is already occupied by inventory service. So our booking service will run on 8081. And we want to add the configuration for our SQL DB. I just copy and pasted this one from inventory service. Now that we've got the application.properties, we are almost ready to test. Let's create a configuration to run our booking service. Let's select the main class. Okay, let's run inventory service first. So if we go to inventory service, we want to make sure that our SQL DB is actually running. So I'm going to do docker compose -v up -d, so it's in detached mode. Our SQL DB is now running. Let's run inventory service. Inventory service is running successfully on port 8080. Now let's run booking service. Booking response has an issue, and I think I know why. Let's just add something as a return. Let's add like an attribute. So booking ID, user ID, event ID, ticket count, price. I think, yeah, we can have these attributes in the booking response. Let's try again. Booking service is running as well on port 8081. So if you open Postman, let's create a new request. It's going to be of type post. Let's add the endpoint of our API. Let's send a JSON object. So in this JSON object, we want a user ID. We want an event ID. And let's have one again, comma. We had another attribute. So if you don't remember them, usually you get this from our API documentation. But for now, if you go to booking service and we go to our controller, we can go to the booking request and see how it's called. So it's called ticket count. So we add ticket count. Let's say 2 tickets. This does not matter. So you might have noticed we have got a user ID, but we never added any user to our database. So if you open MySQL Workbench, you connect to the database, insert a user in the customer table. So you can use this command you see up here. I already ran it, and if we query the customer table, you can see it was added successfully and the ID is 1. Let's go back to Postman and make sure the port is 8081 because we're calling the booking service. If we click send, it was 200 and we've got back a booking response object. Of course, it's null for now because we have not set any of the attributes. And if we go to our booking service, we can see that we had an inventory service response with all the attributes, with the information we need for our booking service. So if we go to our booking service class, we can see that we've got an inventory response back. The next thing we need to do is to check if there is enough inventory. The way we can do it is simply by doing if inventory response .get capacity is less than the request we sent, so get ticket count, we can throw an exception. If we don't have enough inventory, we are not gonna proceed with the order, and in this case we'll just throw an exception. Let's go through what we have so far. We first get customer, we check if the customer exists. If it doesn't, we throw a runtime exception. Next thing, we query inventory service and we check if the capacity is lower than the requested count. Then we throw an exception, not enough inventory. If we pass through all of these conditions, we are now ready to create a booking. Let's now see how to create this booking. If you remember from our diagram, we have performed these steps so far. So we performed step 1, we performed step 2. The next thing is to perform step 3. Now I'll show you how to use Kafka to perform this part of our service. To implement the synchronous call between booking service and order service, we will be using Apache Kafka. So Apache Kafka is an open source distributed event streaming service that is used to handle real-time data feeds. It is designed for high throughput, fault-tolerant, and scalable data processing. It is widely used in the industry, so let me show you how to use it. It has some main components, which are the producers that send the messages. In our case, booking service will be producing the message. We'll have a broker, which is the actual Kafka server that stores and distributes the messages. And then we've got the consumer, which in this case is going to be reading messages from these topics. in our example, our consumer is going to be order service. What we need is to be able to run Kafka on our local machine. In order to do that, we need to actually go to our inventory service. And in our inventory service, we want to open our Docker Compose file and add few more services. So apart from MySQL, we need to add Zookeeper. So Zookeeper is used to manage Kafka brokers. It manages the topic partitions and it chooses who the leader is. So because Kafka is distributed, we might have multiple brokers and brokers might fail, new brokers might be created. All of this is managed by Zookeeper. It is slowly getting deprecated in favor of Craft, but I still want to show you Zookeeper because it's still widely used. Just add these bits here. Next thing we need is a Kafka broker. So this is the actual broker that is going to be listening on port 9092 from the outside. This is the internal mapping. In this case, this is a unique ID you want to assign to our broker. It's useful when you have multiple distributed brokers. In our case, we're just going to have one. We want to define Zookeeper, and in our case, we have defined Zookeeper up here, and it's running on port 2181. And this is not distributed really, so we're just going to have one as a topic replication factor. The next thing we're going to be using is also Kafka UI. So basically we want to be able to see what's going on. It's going to be quite useful in understanding the whole flow of the events and the messages. So you'll need to add this service. And the last one is Kafka Schema Registry. I'll explain this a bit better when we're actually doing the testing, but in simple words, this Kafka Schema Registry basically verifies that the JSON that we are passing to the broker is actually valid. Go ahead and copy these ones. This is actually Kafka broker, so make sure the names are correct. And another thing, notice the ports. So Kafka Schema Registry will be running on port 8083. Kafka UI on port 8084. This is because we already have inventory service on port 8080, booking service on port 8081, and then we'll be having order service on port 8082. So the next one in lines are 8083 and 8084. So now that we got this, let's restart our Docker container. So let me do Docker Compose down. Let's stop whatever it's running at the moment. So I had them already running, but just to show you, let's run the Docker Compose file again. Up -d. These are started. So we've got all the services running for this part. We can now go to the booking service. So if you open the booking service app and go inside the booking service class, we are now ready to create a booking. So this booking is going to be an event that is going to be put on a Kafka topic. We want to create a new package called event. In here, we're going to create a new class called booking event. And this booking event, we're going to add few tags. Some constructors and also a builder. We want to add all the information order service is going to need to place an actual booking. Let's have a quick look at our schema. So for the order table, we need a total, quantity, and a customer ID with the event ID. So in our booking event, we want a user ID, event ID, ticket count, and we want the total price. Let's go back to our booking service. We can now create a booking event here. So if we do booking event, and let's use a private method, I think it's going to look way cleaner. So create booking event, and we're going to pass the request, the customer, and the inventory response. So let's create this private method down here. This is going to return a booking event. we're going to pass the booking request, customer, and inventory response. And then we're going to build a booking event object. We want to get the user ID from the customer, the event ID from the request. Let's get the number of tickets from the request as well. And we want to calculate the total price. So the error is because we cannot apply the multiply operation to big decimals. So we need to use the actual method called multiply. Let's do this. Let's do multiply by the ticket count. So we'll get the total price, and this is a long, so let's transform it into a big decimal. So our booking event is now ready. So if you go back up in the create booking method, we have a booking event. So we want to send this booking event to order service on a Kafka topic. This is where Kafka is going to be used. So you will need some dependencies, which we should already have because in the Spring Initializer project, we already included Apache Kafka for Spring. We already have the dependencies. You shouldn't need to add anything else. If you go to booking service, now we want to create a Kafka template. This is what will be used to be sending our messages on Kafka topics. So let's import and let's look at how we created it. So to a Kafka template, we want to be passing a key, which will be a string. And we want to be passing our event. In this case, it's going to be our booking event. And then you want to give it a name. Let's auto-wire it. And we're now ready to use it. So we want to use it by simply calling Kafka template.send. And here you want to give the name of a topic. In our case, we'll be calling it booking. So our topic will be called booking, and on booking we'll be sending a message called booking event. And now let's add some logging. So let's use proper logging using SL4J. So if you go up here, let's add a tag SLF4J, and this is going to help us with logging. So log.info, and let's also change this one, log.info. It looks a bit nicer and it's more flexible for logging. It's actually made for that purpose. We put an event on a topic in Kafka, and we can simply return a booking response. So we want to create a booking response object where we now fill all these parameters. So if you go back here into booking response, just make sure that these are properly defined. Booking ID is going to be a long, user ID. We've got an event ID, so we actually don't need a booking ID because we don't know what the booking is. That will be defined by order service. So let's remove this. We'll be sending back a user ID, an event ID, a ticket count, and the ticket price, which should be a big decimal, not a string. So please change that. So now if you go back to booking service, we simply take each of these parameters from the booking event and we set it as a response. So total price, there is an error. Okay, so this should be called total price, not ticket price. The error is gone. We are almost ready to test this. We need few more things in the application.properties to be able to run this. So if you open application.properties, we need to add some configurations for Kafka. So the first one is we need to let Spring Boot know where this broker is running, and we are running this on port 9092. If you go to inventory service into Docker Compose, you can see here that our broker is exposed on port 9092. The next thing we need to define is the name of the topic. On our booking service, we've decided that the topic will be called booking. You can give it any name you want, but just make sure you then define the default topic in application.properties. And you want to define a serializer for the key, and in this case it's a string. We want to define a serializer for our value. In this case our value is a booking event, and we want it to be serialized as a JSON. So we are now ready to run this. Let's start up inventory service. Make sure that your Docker Compose has run successfully as well. I've started the inventory service successfully. Let's start up our booking service. Let's go to Postman and let's send a request to our booking endpoint. So let's click send. We can see that we get back all the parameters. Now, instead of nulls, we actually get values. If we look into our booking service logs, we can see here the log says booking sent to Kafka. And if we go up here, we can also see all the logs generated by the producer configuration for our Kafka broker. How do we know that this is actually gone onto a topic? This is where our Kafka UI will come handy. So you want to go to localhost 8084. Here we want to create a cluster. Let's give it a name. Let's call it localhost. And the host is actually called Kafka broker and it's running on port. We can find the port in the Docker Compose 2092. Make sure to use this port. Let's validate to see if it's successful. So this configuration is valid. Let's click submit. If you refresh the page, we can see we've got our cluster created and our cluster has 3 topics. These are some internal topics, but the one that we care about is this booking one. And if we go to messages, we can see our message. So this message is sent as a JSON. We can even produce a message from within Kafka UI. You will be passing a message and you have to make sure that the message value is JSON. So you can have a look around. You can see there are some headers and this is the value. If we now go to Postman and let's say we send another request, this has been sent again. Let's go to Kafka UI. Let's go to topics and we can see we've got 2 messages now. So if you go inside, we open the messages, you can see the time and we can see this is the correct payload. So the messages are getting produced and our message producer is the booking service. We want to be able to consume these messages in another service and this service is called order service. So far we have implemented this step here. So we have booking service that puts messages on a topic in Kafka and now we want a consumer of these messages. So we want to create order service. So in the next step we'll see how to create a consumer of these messages we've been putting on this Kafka topic and I will show you how to do that in order service. So let's go on Spring Initializer and let's create a new project. It will be the same as the other ones. We'll be using Java with Maven, Spring Boot version 3.4.2 and Java 21. We need to add some dependencies, so let's add Spring Web, Lombok, Apache Kafka, as we're going to be the consumers. And we need to add MySQL, Dryware, and Spring JPA. This is all we need, so let's generate and let's open this in IntelliJ. So here is what we have. This is going to be simpler than the other 2 microservices. So the first thing we need to do is to create a service class. We are not going to have any controller here, as order service is going to be picking up messages from Kafka topic. So let's create a service package and in here let's create an order service class. Let's tag it as a service class and we also want to add logging. So let's add SLF4J. Because this is going to be a consumer, we are going to be using Kafka tags to do that. So you want to do @Kafka and it's called Kafka listener. We want to give it a topic name and a group ID. So this topic has to be the same one as the one we chose on booking service. This is the topic where booking service puts the messages and it's the same topic we want to listen messages on. And this will be a public void and we'll call it order event. Here we're going to be taking in a booking event. So we need to be a bit careful here. I'll show you what I mean with that. So let's call it booking event. And let's add some logs. So log.info received order booking event. So let's add that to the log. And now the next steps are we want to create an order object for the database. So we want to save this order to our MySQL DB. And the next thing we want to do is to update our inventory. So these are the two main steps in here. This booking event needs to be the same object that we're sending in the booking service. Let me show you what I mean. If you open the booking event, this booking event is at this specific path, and that's the same one we want in order service as well. One of the options is to go into the pom.xml of booking service and create a jar and then import this as a dependency in order service. But the easiest way we are going to do for this video is we are going to recreate this tree directory with the same class inside booking service. So com.example.leetJourney.bookingservice.event and a booking event class inside. And that's the one that our order service, our consumer, is going to be using to deserialize the messages from the topics. So instead of talk, let's just do it. In here, we want to create a new package, com.example.leetjourney.bookingservice.event. And in here, we want to create a new class called booking event. And the content of this class is going to be exactly the same as the one in our booking service, in our producer. So let me just copy that. So I hope this was clear. We had to recreate this tree because in our listener, we want to reuse the same class that our producer used. There are various ways, more elegant ways to handle this, such as a shared client between the two classes, or have like a jar where you can have these kind of objects that are shared between two services. In this case, this is the easiest way for us to do it. Okay, so make sure the rest of the code goes inside this other package, the one specific to order service. We want to create an order using the details from the event we retrieved from the topic. So this is a booking event, and we'll use it to create an order. So we need to create this order class. This is going to be an entity. So let's create a new package called entity. Let's create a new class called order. And this order class, as I said, it's an entity. So let's add the entity annotation, data. Let's create some constructors. Let's create a builder, and let's define the table name. So the table name is the one we have created using the DB migration, and it's called order. And if you remember, I told you that this order name, it's a reserved word in SQL. So we want to use backticks to escape this. Make sure to add these if you have the same name as mine. Next thing are the attributes. We can find these attributes inside our DB migration. If we go to inventory service and we go inside the DB migration, create order, these are the attributes we need to add to our order class. We are going to need these ones. So we have an ID. We need to add the ID tag. In the DB, the column is called total, but in our application, I decided to call it total price as it's more readable. And we got a ticket count placed at, make sure this is a timestamp, so add this tag. And then we got our foreign keys. So our entity is now ready. If we go back to our order service, we should be able to import it. Let's call order. So it's not giving me the option to import. We can add it manually. So com.leetjourney.orderservice.entity and order, and the error is gone. And now we want to create this order. So I've added a private method so that the order event method is more readable. Private. We want to return an order object, and we want to create an order. We are going to be passing in a booking event and then create an order from the attributes in this booking event. Just want to remind you, this booking event will be retrieved from the Kafka topic called booking. We have our order. Now we want to save it to the MySQL DB. So we need to create an order repository, and then we want to save this using JPA. we want to save this order object. So let's create a new package called repository. And in here we want an interface called order repository. We want to extend JPA repository, and it's going to be an order class, and long is the identifier, and we want to tag it as a repository. So if you go back to our order service, we can auto wire this into our order service class. So private order repository, let's import, and now let's create the constructor for order service, and let's inject this order repository. Okay, so this order has been saved to the DB. Next step is to update our inventory. To update our inventory, we need to do a few things. First is we need to check if inventory service has an endpoint that we can call to update our event inventory. So if we go inside the inventory controller, we can see that these are all GET requests. There is nothing to update. We're going to create a put endpoint that we will use to update the inventory for our event. So let's create it. So it's a put mapping. This looks correct. And we want to update our event capacity. So we're going to be passing two path variables, the event ID and the capacity. This is how many tickets have been booked, so that we can subtract them to the current capacity for this specific event. So in inventory service, we are going to create a new method called update event capacity. So if you go in inventory service, let's add it here. So update event capacity, it will accept an event ID, how many tickets have been booked, and simply will first retrieve this event from our DB by event ID. And then we will set the left capacity by taking how many tickets are left and subtracting the numbers we have booked. And then we'll save this to our DB. So actually let's do save and flash, and let's add some logging. Let's say update event capacity for event ID with tickets booked, and this looks good. We need to add a logging, so let's add the tag slf4j. So we've got our endpoint ready in inventory service. It was quite simple and quick because we've got everything in place. Let's go back to order service and let's create a client for inventory service. And we'll be calling an update inventory method inside this client, and we will be passing the event ID and the ticket count. Let's create a new package called client, and let's create a new class called inventory service client. This is a service class. We need to define a value, so we need to add this into our application.properties, the URL we want to query. So if you go to resources, application.properties, let's add that down here. Inventory service is running on port 8080. This is correct. This is the base URL. And in our inventory client, we can now assign this to a string. Next thing we want to do is create the actual method. So response entity as a void. We want to update inventory. We'll pass an event ID and a ticket count. We now want to create the actual call to the inventory service. So we're going to use a REST template. And now we can do REST template.put inventory service URL event plus event ID. Capacity is the ticket count. And we can simply return response entity .ok.build. In the service class, we want to inject the inventory service client inside our constructor. So now we have updated the inventory. Let's add the log. And let's say inventory updated for event, less tickets, the number of tickets we have booked. And we are almost ready. So we got a slight error there. We need to define few properties. The server.port order service will be running on port 8082. Let's add our MySQL DB configurations. And we need to add our Kafka configurations. So make sure that these are correct. In the booking service, we had the key serializer. Instead, here we've got a key deserializer, and same as the value, it's a string deserializer in this case. For the value, we are using a JSON deserializer. In here, we also need to add the JSON type mapping or the event Kafka listener. We are using this booking event, this class here. And that's the one we want Kafka to use to deserialize our messages. So this is quite important. So this is all we need. We are ready to place our first order. Let's go to inventory service. Just make sure your Docker Compose is running successfully. If not, just do Docker Compose down and then do Docker Compose up. But we already have this running from the previous step. Let's start inventory service. This has started successfully. Let's start booking service. This has also started successfully. And now we want to start our order service. So we need to create a configuration, call it order service. We want to run the main class. Apply, okay, and let's run. Hopefully there are no issues. Okay, so looks like this is running correctly. Let's go to MySQL Workbench and let's make sure there are no orders. So there are no orders. Every time we restart our Docker containers, we will need to recreate this Kafka cluster. So that's what I'm doing here. I'm just doing this so we can see what's going on. I have quickly recreated this. We've got our topic booking. We've got 0 messages. Let's just do a GET request using Postman to our inventory service for event 1. And let's see how many tickets are left. We've got a capacity of 39,900. Let's place a booking now. So we want to place a booking for user ID 1 to event ID 1 and a ticket count of 10. So let's see if this goes through successfully. Let's check our order service logs. So we received an order event. Inventory got updated. Let's verify that the order has been placed in our DB. So we've got our order. We've got the total price 100 and we ordered 10 tickets. If we go back to Postman, let's do a GET on the event to see if this capacity has been updated. Capacity was updated. Let's place a couple more orders. So let's do 30, for example. Let's send a couple of orders. Let's see if the capacity decreases. It has decreased. And if we go in our MySQL Workbench, we can see all these orders have been placed. So what is happening here is we are publishing messages on this topic. These were our messages and these are being picked up by the consumers. So order service has created a consumer with group ID named order service. And this is the one that has been picking up our messages from this topic. So I hope this part was clear. So this is what we have done so far. Booking service has placed a message on this topic. So it shouldn't be a queue. It's a topic really because we're using Kafka. Then order service as the consumer of this topic has been picking up messages from here. It gets the message, it creates an order and saves the order in MySQL DB. After placing the order, it does a synchronous call to inventory service, and the inventory service updates the inventory for our event inside our main database. So we've got our main flow, our main logic. The next thing we want to do is look at this API gateway. Let's start by looking at what an API gateway is. So in simple words, an API gateway is a server that acts as an entry point for client requests and routes them to backend services. It acts as a reverse proxy, handling authentication, request transformation, rate limiting, and also other operations, but these are the main ones. API Gateway brings a lot of benefits to microservices architectures. It offers a centralized entry point for clients. We can use it as a load balancer and to determine routing. It is also used for security and performance optimization, along with API versioning, monitoring, and protocol translation. All of this sounds good, but there are also some drawbacks. For example, this introduces a single point of failure. It increases latency as we have an extra step to go through. Having an API gateway service also increases complexity in setup and maintenance. And there is also the possibility for a potential bottleneck, as all requests will be hitting API gateway. But that's not a big issue because we can simply scale horizontally by adding more instances. In this video, we will be using Spring Cloud Gateway, but before that, let's have a look at few diagrams to better understand what we're trying to achieve. In this diagram, you can see that we have an API gateway, but you might have noticed that using Postman, we're calling directly booking service and inventory service. And that's because we still need to build this API gateway. So let's see how that's going to work. On the left, we have the current way we are using booking service and inventory service. We are using Postman to directly call these two services. What we want to achieve is this one on the right. We want to be able to call API gateway, and then API gateway will route our requests to either booking service or inventory service. Right now, when we want to call booking service, we send a request using Postman with the full URL of what we want to call. And this URL is the same as the one defined in the controller in the booking service. And the same is true for inventory service. But let's say we wanted to change our inventory service to a warehouse service. Let's say we wanted to change its name because the way it functions is going to change, or we want to substitute inventory service with a brand new service called warehouse service. In that case, our client will need to be calling this new endpoint, and we will have to do changes in Postman to support this. So just imagine you have thousands of clients that are relying on your API. You don't want this to happen. You don't want to go through the hassle of having your clients change all their endpoints if they were using your service. So for example, you could have 10 endpoints. You don't want to go and tell your clients to change all these endpoints. That's where API Gateway comes in hand. If we were to introduce an API Gateway, this is how the request forwarding would look like. So API Gateway would have its own mappings of the backend services. The client will be still calling the inventory endpoint, but just notice we will be calling port 8090 in this example, which is the port of our API Gateway. And then API Gateway knows where to route the request. Let's say we want to call this endpoint to get inventory. Our client will send it to the gateway. API Gateway knows that in the background, we now want to call our warehouse service. When the request hits API Gateway, it will be transformed and it will be sent to the actual service, in this case, the warehouse service. So here is a graphical example of what I just described. Inventory service is not available anymore, or we have decided to deprecate it, and we now want to use this warehouse service. Our client will be unchanged. The only thing that will change is the mapping in the API Gateway to call warehouse service instead of inventory service. We are now ready to write some code. API Gateway is going to be another service in our architecture. So go on Spring Initializer and let's create another Spring Boot project. Again, I will be using Java with Maven. I'll be using the latest Spring Boot version 3.4.3, and I'll be using Java 21. Give it a name and let's add the dependency. We want to use the first one, which is called Gateway. Let's add it, and that's all we need. Let's generate and let's open this project in IntelliJ. I have opened our project. We want to add routing information into our API gateway application. So let's start by creating a package. Let's call it route. And now let's create a class called inventory service routes. Also, let's create booking service routes. You might be wondering, why don't we have an order service routes? And that's because order service does not have an external API endpoint. So we cannot call it. Even booking service does not call order service directly. We go through a queue. So we just need inventory service routes and booking service routes. Let's start by looking at how a route looks like. So this is a configuration class. You want to add this tag. And next we want to create a bean. And it's going to be a public router function that returns a server response. Let's import that. And this is going to be called booking routes. So I wanted to start with booking service as it's the easiest one between the two. Inventory service has more endpoints. Here you want to add the actual route. We're going to return a gateway router functions dot route. Let's give it a name. So the route ID is booking service. And let's define the actual route. The request will come to this endpoint here, and it is a post request. This looks correct. Let's build, and give me a moment, I'll explain what I've written. The external route is this one, API v1 booking. So whenever a post request comes on this route to API gateway, we want to forward this request to this endpoint, localhost 8081 API v1 booking. Let me just show you what this is. This is the same request path we have defined in our booking service, API v1, and a post request on the path booking. So simply what's going to happen is we will be calling API gateway on this endpoint, and it will be routed to this one. You can even call this book tickets, or you can give it other names, and that's the beauty of using an API gateway. It makes it easier to handle API requests. But I will just change it back to booking. So we've got the routes for our booking service. Let's also add a couple of routes for inventory service. So this is a bean. So it will be the same as before. It's going to be a router function response inventory routes. So we want to do something similar to what we did before. So we're going to return a gateway router functions dot route. We want to give it a route ID. We'll call it inventory service. And now we want to define the route. So let's have a quick look at inventory service first. We are just going to be defining these two routes just to give you an example of defining multiple routes for the same service. But as you can see, we have a path variable, and this is where we need to do things a bit differently compared to the booking service routes. So let me just show you. Let's go back to our API gateway, and here we're going to be adding these 2 lines, actually 4 lines. I'll just copy and paste. It's gonna be easier to explain. And we need also a helper function, and then .build, and this should be all we need. So what have we done? Same as before, we had defined the path that we will be calling in API gateway, which is this one. And we want to forward this request onto this URL. As you can see, this is the inventory service URL. But the different thing is we need to handle the path variable. And to handle the path variable, I had to create this helper function. It's quite easy to understand. We are basically just going to get the path variable from the server request, and then we're going to create this handler function. Quite simple. If you wanted to add a new route for inventory service, you can just add the route and do the same as above. But I'm just going to add these 2. The last thing left to do is simply to add a port where this API gateway will be running. So I will be running it on 8090. Let's add a configuration. Call it API gateway. Main class, just select it. Click apply, OK. By the way, before just running that, I wanted to add that we can do this nicely as well. Instead of having the base URL hard-coded, just add it in the application.properties, and then using the value tag, just import it in this configuration class. One thing we forgot is to add the configuration tag to inventory service routes. We already have it on booking service routes. So we are now ready to run this. You want to make sure that the services in the Docker Compose are running. And then let's start up inventory service. This has started successfully. Let's run booking service. This has started successfully as well. And let's run order service. This has started as well. And now let's start up our API gateway. This has started as well on port 8090. Now, using Postman, we want to make sure that we can still create bookings, but instead of using booking service, we want to go through API gateway. So let's change this port number to go through API gateway and make it 8090. We can leave the body the same. Let's click send. And as you can see, this was sent. We have a 200. And let's see if we can call inventory service endpoints using API gateway. So let's change the port to 8090 and let's see if the capacity has decreased by 300 because we just did a new booking. It has decreased by 30. We booked 30 tickets. Let's say we want to book 50 tickets. Let's send. Query the inventory and we can see it has decreased by 50. So as you can see, our API gateway is working. The next step is to protect our backend service. We don't want anyone to be able to just call our backend service. So I'll show you how to add some kind of authentication on our endpoint. As we can see from the diagram, I have introduced a new component which is called Keycloak. Keycloak is an open source identity and access management resource that provides authentication, authorization, and user management for application and services. It supports single sign-on OAuth 2, which is the one I'll be showing you, SAML, RBAC, multi-factor authentication, and LDAP as well. But the one we will be using to protect our API gateway and the backend services is OAuth 2. So we want our client to be authenticated, and I will show you how to do that using Keycloak. The first thing we need to do is add a couple more services in our Docker Compose. So open inventory service, go to the Docker Compose, and let's add 2 more services. The first one is a Keycloak database, and the second one is the actual Keycloak instance. So go ahead and add these 2 services to your Docker Compose. The first one is a database. It's again a MySQL DB. We have defined the database name, root, and password. And then we need to define the actual Keycloak service, which depends on this database. So there are few things we have defined, such as environment variables. We have a Keycloak admin username and a password. We will need these 2 later. And you need to define a port. So I've chosen 8091 as 8090 is the one running API gateway, and the next one will be the one for Keycloak. And once we have this, let's run Docker Compose app -d. So this is running successfully. Let's test. Open a new browser page and let's go to localhost 8091. So we're going to be using admin and admin as password. And this is what you will be shown. So we can see that we are in the master realm. What is a realm? I'll show you in a bit. We now need to create a new realm. So just click here and click on new realm. A realm is basically a set of users' credentials, roles, and groups. And realms are isolated from one another, and they can only manage and authenticate the users that they control. So generally for each application you're running, you will have a different realm. in our case, we will be calling this realm ticketing security realm. We want to enable it, and let's create. So a realm was created successfully. Make sure it's selected from this drop-down menu. Let's go to clients, and we want to create a new client. We want to give it a name. I will be calling it ticketing client ID, and the rest is not compulsory. So let's click next. So here we do want to activate client authentication. We want to authenticate our client requests. In this case, for us, the client is Postman. Let's deactivate the standard flow. If you click on these icons, you'll see what these are. Let's also stop direct access grants. This is the one that accepts username and password. Instead, we're going to be selecting the service account roles. We will be able to use client credentials to get a JWT token and use that for authentication. Let's click next. We don't need anything here. Let's click save. And the client was created successfully with this client ID. We will be needing this client ID and these credentials, so this client secret. You can regenerate this. That's the good thing. Let's say this gets compromised, you can simply regenerate one, or you should be also able to add key rotation, but that's not in the scope of this video. We will be using this credential. So now let's go to realm settings. And if you scroll down, we have OpenID endpoint configurations. So these are a bunch of information we are going to need to set up our API gateway to implement Spring security. So I'll show you the ones we need later. Now that we have configured our Keycloak, we can now go to API gateway. So in here, we need to open our pom.xml and we need to add a new dependency. So if we go down to dependencies and let's add a new dependency, and what we need is Spring boot-starter OAuth2 resource server, and the group ID is org.springframework.boot. Let's reload, and this dependency should be pulled. Now let's create a new package, and we're going to be calling it config, and this is where we will have our security configuration. So let's create a new class and let's call it security config. This is going to be a configuration class. We need a bunch of things. So we want to create a bean, and this is going to be a public security filter chain. Let's import and security filter chain. It's going to accept an HTTP security object. And here we will need to return a HTTP security.authorize HTTP requests. We're going to have a lambda requests, and authorize requests. We want to authorize any request authenticated, and then we want to do OAuth2 resource server, another lambda, and we want the OAuth.jwt to accept a customizer with defaults. And now we can build this object. Make sure to add this throws exception. We also need to add a new bean. So this bean is going to be a public JWT decoder. Let's import, and we're going to return a Nimbus JWT decoder with JWKS set URI. So this is a decoder, and we'll use this to get our JWT and authenticate it with the Keycloak public key. We need to define this Keycloak auth JWK set URI. So we want to add this in our coder. So Nimbus. Let's import this, and now let's go to application.properties. In our application.properties, let's define Keycloak properties. So the first one is we need to set this JWK URI. Let's go back to this page, and we can see there is a JWKS URI. This is the endpoint that our API gateway will send the JWT to get it verified, basically. In simple words, that's what's going to happen. So let's add it here. And we also need another property. We need to define the JWT issuer URI, and we have this one. This is the one you can get from up here. This is the issuer URI, and this is the one we need. So just also add this second property. So this should be all we need to add security to our API gateway. Now let's run our services. So let's make sure our Docker Compose containers are running. Let's run inventory service. Let's run our booking service. And let's run our order service. Let's also run our API gateway. Let's open Postman. So let's try to send a request without adding any authorization. Let's see what happens. As expected, this is returning a 401 unauthorized. So we need to add our OAuth2 token. To do that, we can go to authorization, select OAuth2. If you scroll down, let's go to configure new token. Let's give it a name. I called it token. Grant type, we're going to use client credential. We need an access token URL. So if you go back to our page, here we can find our access token URL, which is the token endpoint. Let's paste it here. We need our client ID. We can find our client ID by going into our realm, then clicking clients and going inside our ticketing client ID. Let's copy. Let's paste it here. The next is the client secret. So from within the client, let's go to credentials and let's copy this client secret. Let's paste and make sure you have this OpenID roles. Leave client authentication as send as basic auth header. And now let's click on get new access token. Authentication complete. Let's click proceed. And we can see this token was generated. So it's a bearer token that we will be sending as part of our request. So click on use token. And this token has been added up here as a bearer. So it will be sent as a header in our request. So if we now click send, we can see that we got a 200 back and authentication is working. So we have ordered 50 tickets. Let's see if the inventory service is protected as well. We can add OAuth2 and let's get the token, proceed, use token. These were autofilled, by the way. You just need to do it once. Let's click send and we can see that this is working as well. So in this section, we have added security to our API gateway. What this means is that any client, before being able to send requests to our backend, will need to go through the API gateway, and API gateway will need to authenticate the request. So the client will be getting a bearer token. This will be sent to API gateway. API gateway will take this token and then verify it with Keycloak. If it is valid, it will forward our request to either booking service or inventory service. In the next section, we are going to see how to make our architecture resilient to failures. So now let's see how we can implement some resiliency in our microservice architecture. So let's assume we have a booking service that goes down or it has some kind of issues connected to the DB server. API gateway is still going to be accepting requests and it will try to send these requests to booking service and wait for a response. But because booking service is not in a healthy state, API gateway is never going to be getting a response back and booking service will simply be overloaded with requests. Same thing goes for inventory service. Or something similar could even happen in this request here, the request number 5. Order service could be calling inventory service to update the inventory. But for some reason, inventory service could be down and it will simply be overloaded with requests. In this case, we can implement a pattern which is called the circuit breaker pattern. This is how it would look like. We are going to be using Resilience4j as the circuit breaker pattern implementation library. And what will happen is if booking service is failing to respond within certain set thresholds, our circuit breaker is going to stop all requests going from API gateway to booking service. And we can define some parameters to allow some requests to go through even when they are failing, just to make sure that booking service is still unhealthy. And if we do get a response back, we will send it back to our client. And then the circuit breaker will be going back in a closed position. So let me explain it a bit better. A circuit breaker can have 3 states: a closed, open, or half open. When the circuit breaker is in a closed position, everything is good, requests are going through. But let's say some requests fail and this failure is greater than the threshold we've set up. The circuit breaker will move to an open state, and in this open state, it will be stopping requests going to the downstream service. After a certain threshold, it will move to half open. In this half open state, we will let few requests go through to our downstream service. And that's to determine if that service is back up again. If not, we will go back to an open position and we will start throttling the requests. But once the failure rate is below a certain threshold, we will move our circuit breaker in a closed position and all the requests will flow as normally. So these are the 3 main states. Let me show you what we will be using to implement this pattern. We will be using Resilience4j. It's a lightweight library that is designed for this specific purpose. It also offers other patterns such as rate limiter, retries, or bulkhead. The one we are interested in is the circuit breaker. So let's go back to our API gateway and we need to add a couple of dependencies. So if you go to pom.xml, let's add a new dependency. And we want to add Spring Cloud, Starter, Circuit Breaker, Resilience4j, and this is from the org.springframework.cloud. And the second dependency we want to add is Spring Boot, Starter, Actuator, and this is from org.springframework.boot. This second one is used to track the status of health endpoints and find the health of the circuit breaker. It will be clearer in a bit, I'll just show you. So let's import these dependencies and let's go to our application.properties. We need to add a number of properties, so instead of me just typing, I'm just going to copy and paste and we'll go through these properties. So we will need all of these. So we need these 3 properties for our actuator. We want to enable the health endpoint for the circuit breakers. We want to do this for all the endpoints and we want to show the details always. The next bunch of properties is specific to Resilience4j. We're going to be using a sliding window of type count to check our thresholds. We're going to set the size of our sliding window. We will be checking 8 requests at a time and we want to set a failure threshold. So in this case, it's 50%. So if 50% of these 8 requests fail, we will be moving our circuit breaker from a closed position to an open position. We also want to set up a minimum number of calls because as soon as we reach 4 calls, we want to see if the first 4 calls are failing, we want to activate our circuit breaker. We don't want to wait for all 8 of them to fail. We want to set up a duration in the open state. If our circuit breaker activates, we want it to stay in an open state for at least 5 seconds. We also want to allow some requests to go through when we are in half open state. In this case, I've set up 2. And we also want to automatically transition from open half to open enable state. So we want to set this to true. We can also add some timeout limits, in this case 3 seconds, and we can define some maximum attempts with a minimum wait duration between these 3 attempts. This is all we need in our application.properties. Now we can simply go in our booking service routes and let's add a filter. This is going to be using a circuit breaker filter function and we're going to define a name for this. I called it booking service circuit breaker. And when this circuit breaker activates, we want to forward this request to this endpoint. But we don't have this endpoint yet, so let's create a new bean. And this bean will be handling with all of our failure requests. Let's just call it fallback route. And this fallback route will be called when the circuit breaker is activated. And we want to return a message saying booking service is down. This is all we need to implement a circuit breaker. Let me show you the circuit breaker in action. So make sure inventory service is running. Do not run booking service for now, so I'm going to stop it. Also, let's have order service running. I assume that all of the services in Docker Compose are running. So the last service to run is our API gateway. So let's run this. This has started successfully. So let's go to Postman and let's check the actuator health endpoint to see the status of our circuit breaker. So we need to generate a new access token. Let's send a request. And our circuit breaker is in a closed state at the moment. So this is good. It means the requests are going through. Now let's go back to our post request to send a booking. Let's generate a new token and let's send a request. So if we send 1, 2, 3, I've sent 3 requests. This should still be in open state, in closed state. And that's because we have not reached the threshold yet. If I go back to booking, I send few more requests. As soon as it goes above 4 requests failing, our circuit breaker already went into a half open state. Now, if we send a couple more requests, let's check back. Our circuit breaker is back into open state. Let's send few more. Still in open. And now it's half open because after 5 seconds from open it goes to half open to allow some requests to go to the downstream service. Let's go to our booking service. Let's start it up. And let's send some requests now. So when I send one request, this has gone through. Let's check our circuit breaker is still half open. So let's send 2 more requests. Let's check the health. And now our circuit breaker is in a closed state because our booking service is back up healthy. And because we have also added timeout durations, what this means is if an endpoint times out for more than 3 seconds, it's going to be considered as a failure. So you can also do that test. You can simply add some kind of wait in the booking service endpoint. And when that wait will be triggered, the circuit breaker is going to get activated. What we have just seen is a nice and easy way to protect our system from overloading when one of the services is down. If booking service is down, it will stop getting requests for no reason because it's not able to process them. And once it's back up again, it will be able to keep processing requests coming from the API gateway. But up until this is not healthy again, our circuit breaker is going to be acting as a valve and it's going to stop requests from overloading our downstream service that is already struggling. The last step of our video is to create some API documentation. So you must have seen something similar if you've been trying to integrate a third-party API in one of your applications. So this is the Stripe API documentation, and as you can see, it has some examples of requests. What this allows is Stripe to onboard people without having to manually go there and tell them, oh, this is what you need to send to this endpoint. And this is a standard in the industry. If you want people to onboard your API, you just send them the API docs and you should have everything they need to understand what your API endpoints are expecting to receive. So it's a nice and easy way to onboard people to get to use your API endpoints. So to create that kind of API documentation, we are going to be using Open API specification, and as its implementation, we are going to be using Swagger. So some people use this interchangeably, but the difference is that OpenAPI is a specifications. It tells us how API documentation should look like, and Swagger is the actual implementation. So we will be using these tools. Let me show you a quick diagram. We will be initially exposing API docs for booking service and inventory service directly from within the application. But because we don't want anyone accessing directly our internal applications, in this case booking service and inventory service, we will need to expose these API documentations through API Gateway using a unified UI to show both of these documentations, and I will also be showing you how to achieve that. You must have noticed that order service is not going to get any API documentation, and that's because we don't have any endpoints to expose. Let's start with some code. The first thing we need to do is we need to go in inventory service and let's add some dependencies. If you open your pom.xml in inventory service, we will need to add these two dependencies. The one at the top is going to help us generate the nice looking UI page we've seen. And the second dependency is going to generate a version of our API documentation that is accessible through API endpoint. So it's going to generate our documentation in JSON format. So just download the Maven changes. This will pull the dependencies. Now let's go into our application.properties. So if you go to source, main, and application.properties, we want to add a couple of properties. So the first one is springdoc.swagger-ui.path, and this is going to be the path where we will be able to access our API documentation. Let's also define the path for our API docs as a JSON that people can access through an endpoint call. So we need these two. Now let's start inventory service and let's see what gets generated. So inventory service has started successfully. Let's go to our browser and let's go to localhost 8080/swagger-ui.html. As you can see, we've got a nicely formatted API specification document where we have each endpoint with the respective parameters that it's expecting. For example, we've got a bunch of gets and our put endpoint. You can see a response object of this get request. And at the bottom, we've also got the schemas. So it tells you exactly which kind of object is going to be returned quite in detail. So this is really useful. This is the UI part. Let's say you want to access this documentation through an endpoint call. You can simply call this endpoint up here, localhost 8080/v3/API docs, and this will be sent to you as a JSON object. It will have the same content as the UI. But if you go back to the UI, we can see that it says OpenAPI definition here. We want it to say the title of our application. So we want to change this, and I will show you how to do that. Let's go back to inventory service, and we want to create a configuration package where we're going to add a configuration class. So let's call it OpenAPI config, and this is a configuration class. So let's add the tag, and we want to add a new bean that is going to return an OpenAPI object. So actually we want to call it inventory service API, and we want to give it a title. So inventory service API, and same as here, we can see that we've defined a bunch of attributes, but there are many more that you can go and customize. You can add contact information, you can add terms of service, licenses, summaries. It's quite flexible. That's all we need. If we restart our inventory service, we go back to our browser page and let's refresh. We can see that the title has changed and we've also got a description. This is a bit more customized and looks nicer if you want to send it to someone. Let's do the same thing to booking service. So let's add these two dependencies we've just added into inventory service. So if you go to pom.xml, let's add these two dependencies. Let's go to application.properties and let's just copy them from inventory service because they are the same. And let's add a configuration class here as well. So let's create a package. Let's go to inventory service. Let's copy the content of OpenAPI config. Let's create an OpenAPI config class here. It's going to be a configuration class, so let's tag it as such. Import these dependencies. So let's change the name. So this is booking service. If we now run booking service, so the application has started successfully. Instead of port 8080, we want to go on port 8081. And we can see we've got back the endpoints in booking service. In this case, it's just a booking API. I wanted to show you quickly something. So if you go back to inventory service API documentation and you expand one of the GET requests, you can actually try it out. So what this is going to do is going to send this GET request to our backend service, and we actually get back a response because we have our service running in the background, and we do get back a good response. But what you might have noticed is that we've been accessing this documentation directly through inventory service and booking service, but we don't want external people to access these services directly. And because we got an API gateway, which is the entry point to our backend system, we want people to access this documentation through API gateway, through port 8090, which is where our API gateway is running. So let's do some changes. Open up API gateway and let's add the same two dependencies we added for inventory service and booking service. So I'll just go to inventory service and I'll copy them. Let's go to the application.properties now. So this is where things are going to be a bit different. Okay, we want to add the same Swagger UI and API docs path, but we want to use API gateway to also access booking service and inventory service documentation. And to do that, we need to define some other properties. We want to define the name of each service and the corresponding URL. We want to define the name inventory service and the URL, which is going to be docs inventory service v3 API docs. This is a URL I have defined. Instead of docs, you could have something else such as Open API, or you can have gateway instead of docs, whatever works for you. But generally speaking, docs it's quite good to use as a aggregate documentation URL. And the second one is the booking service. We want to do the same thing. Only thing that is different is the service name. In this case, it's going to be booking service. This is where things get a bit different. We want to go in booking routes and we want to define a new route, and this route is going to be used to go to our API documentation in booking service. So this is what we need. We need to create a new route that basically is going to be called at this endpoint here, which is the one we have defined in our application.properties. And this request will be sent to port 8081, which is where our booking service is actually running. And when we are sending the request to this port 8081, we want to set the path to v3 API docs. If you remember, v3/API docs is the endpoint that we can use to get back documentation as a JSON. So that is what is happening over here. And we want to do the same thing for inventory service. So if you go to inventory service routes, let's add the routes for this as well. So same thing as before, we want to create a new bean and we're going to map this URL localhost 8080/v3/API docs. And now if we run API gateway, let's go to localhost 8090, which is where our API gateway is running. You can see that we're getting a 401, and this was totally expected. And that's because we have added authentication to all the endpoints in our API gateway. But we want to expose this documentation to our clients. We want our clients to access this documentation without any authentication. So how can we do that? It's quite simple. Let's go to our application.properties. Let's add a bunch of URLs we want to exclude from authorization. So this is the ones you want. You can notice we've got one for docs/$. That's where our merge documentation will be. So we want these ones. And now we need to go to security configuration. And in here, we want to do some changes. Just after authorized requests, we want to add two new method calls. So request matchers, we want to exclude these URLs we have just defined in our application.properties. So let's add them up here. And this will be mapped to a string of excluded URLs. So what we want to do is any request coming through these URLs, we want to permit all of those. Any other, we want to authenticate it. If we rerun API gateway, let's go back to our browser, and if we refresh, we can see that we've got access to documentation through API gateway. Here at the top, we can select the service we want to see the documentation for. This way, external clients will not need to access our backend servers. They will not need to access booking service nor inventory service, which is what we want. We have built this system which is using quite a lot of components and state-of-the-art technologies which are used in the industry. I hope you learned something from this video. If you're encountering any kind of issue, please just leave a comment in the box below with as many details as possible, and I'll try my best to help you out in debugging. There are a few things that you can do to expand this project. For example, you can add a third-party API call to a payment service. So before placing an order, you can do a payment as well. That would be a nice way to implement a third-party API as well. You could, for example, use Stripe API to do some payment processing. Another thing you could do is write unit tests and integration tests. I've got a video on that as well, so please check it out. And just be creative. This is your project, make it your own. You could add some observability. You can try to add metrics and logs. And if you want me to cover any other topic, please just leave a comment in the box below.